Node.js, JavaScript runtime built on Chrome's V8 engine. Agenda, server-side runtimes, Node.js history. Why Node.js? Event loop lifecycle, getting started, basic workflow, modules and packages. Server-side runtimes. A server-side runtime lets a language execute outside the browser, handling requests, files, and network connections directly. If a request fails, well-designed error handling lets the server recover and keep serving everyone else. Almost every modern web backend depends on some kind of server-side runtime to stay responsive under load. Any team building an API or real-time application needs a runtime that handles many connections at once. Spinning up a new thread for every single connection doesn't scale. Blocking and non-blocking input-output. Blocking input-output makes a thread wait, doing nothing else until a file read or network call finishes. Non-blocking input-output, like Node.js, lets a single thread start an operation, move on, and come back when it's ready. Blocking, thread per request servers, waits until input-output completes, one thread per connection. Non-blocking, Node.js, Nginx, one thread, many connections. Problems with blocking input-output. Single point of failure. One slow request can tie up an entire worker thread. Waste memory spinning up a new thread or process for every concurrent connection. Doesn't scale well past a few thousand simultaneous connections on typical hardware. Hard to keep a server responsive when many clients are waiting on slow network calls. Every team ends up writing its own thread pool, tuning, and connection limits. Misses out on the simplicity of a single threaded, event driven programming model. The Node.js runtime system. JavaScript source is written in .js files and kept in a source or Git repository. Google's V8 engine compiles that JavaScript directly to machine code at runtime. Node.js wraps V8 with an event loop and non-blocking APIs for files, networking, and timers. Other similar server-side runtimes: Lino, Bun, Python's async IO. Node.js advantages: handles thousands of concurrent connections on a single thread without blocking, speeds up development by sharing JavaScript across both front-end and back-end. Huge ecosystem. NPM hosts more packages than almost any other registry. Fast startup and low memory overhead compared to thread per request servers. Excellent fit for real-time apps like chat, streaming, and live dashboards. Backed by a large open source community and every major cloud provider. Everything is asynchronous, almost. One huge benefit is that in Node.js, almost every input-output operation is asynchronous by default. Callbacks, promises, and async await All describe work that finishes later without blocking the thread. The event loop continuously checks for finished work and runs its callback next. A single Node.js process can juggle thousands of open sockets with very little overhead. CPU heavy work is the one thing that still blocks the loop, so it's offloaded to worker threads. Callbacks and promises. Callbacks, a function passed in to run once an async operation finishes. Promises, a cleaner way to chain and await async results. Server.js, a minimal HTTP server, responds to every request without blocking the event loop. Async await. Here, async await makes asynchronous code read like ordinary sequential code. History, created by Ryan Dahl and first released in 2009, built on top of Google's open source V8 JavaScript engine. Designed from the start around non-blocking input-output, aiming to handle many concurrent connections efficiently. NPM launched in 2010, quickly becoming the largest package registry in the software world. A brief community split led to io.js in 2015, which merged back to reunify the Node.js project, now maintained by the OpenJS Foundation and used to power a large share of the modern web's backend services. Why Node.js? Unified language. The same JavaScript runs in the browser and on the server. Non-blocking by design. Built for high concurrency, input-output heavy workloads. Massive ecosystem. NPM hosts millions of ready-to-use packages. Fast iteration. No compile step between editing and running code. Great for real-time. WebSockets and streaming fit naturally into its event model. Backed by the OpenJS Foundation and adopted by nearly every major tech company. Package.json and node_modules. Package.json declares a project's dependencies, scripts, and metadata in one file. Node_modules holds every installed dependency and is rebuilt from package.json, never committed to Git. Package-log.json pins exact versions so installs are reproducible across machines. Scripts defined here can be run with a simple npm run script name. Node.js event loop. Sync code runs, call stack, checks for work, event loop. Result ready, callback queue. Callback runs, execute. Synchronous code runs first. The event loop watches for finished async work, queues the result, and then runs its callback. Getting started with Node.js. This leads us to the three commands that get a project off the ground. Node-v confirms Node.js is installed and see its version. npm init create a new package.json for your project. npm install add the packages your project depends on. Basic workflow, develop backends in Node.js, integrate with frontends, maintain in Git, optimize. Installing, running, and testing. Some call install, run, and test Node.js everyday loop. Fast. npm install pulls dependencies straight from the registry in seconds. npm run dev commonly restarts the server automatically on every file change. npm test runs a project's test suite directly from the command line. The event loop keeps the server responsive even while many requests are in flight. Supports many workflows, REST APIs, real-time apps, CLI tools, serverless functions. Works the same across every OS Node.js supports. Any questions? Thank you.